And welcome on JR.
What's happening, lady?
Welcome everybody. Let's see, we got Al, David out there in the world. We've got Keith and Doug, and we got David Heineke and as well. So, how's everybody doing? All right. So tonight, can everybody hear me? Okay. Tonight we are going to be talking about work holding and work holding principles. Clamping, basically how to secure your material, the different types of clamping, and when you would use one versus the other, what options are available out there in the world. We're going to talk about, I think one of the classes, and I may be mistaken, but I could have swore one of the classes that I did with you guys in the past, I gave you a clamp file for making some hold down clamps and things like that. And if not, then you're going to get that file tonight, in that session. So in this session, hopefully you're all staying warm. This would be a class that I would love to be out in the shop having the discussion with. I'm not saying that I'm not out in the shop because it's cold. It was two topics under one sentence. Sorry about that. Hopefully y'all are staying warm and everybody's doing well and not, suffering too much from the cold and snow and everything, and everybody's being safe and all that stuff. And then second topic, I wish I was out at the shop teaching, but I just couldn't get everything set up in time to do that. I'm really, really wanting to be out in the shop more this year instead of behind this desk. And we're going to try to make that happen coming up. All right. Give me just a second. Give me just a moment and let me get everything kind of organized here. First of all, I want to pull up on my side the clamp file that I just mentioned to you. And I want to make sure that I have a download link for you all. So give me 2 seconds to pull that together real quick. Master files. Information and how to. All right. So minimize this and go to Google Drive. Give me a second. I got to create a link for y'all and then we'll get started. We'll get really rocking and rolling. I'm running a little bit behind the 8-ball here. All right, Drive. SpindleTV files. Okay, let me give this a name. CNC clamp for exclusive members. Drag and drop that over here. Open that folder up. Where are you guys at? Right there. Share. Almost there, ladies and gentlemen. Anyone with the link? JR, how you doing, buddy? You doing all right?
Just trying to survive the freeze, man.
Good, man.
It's getting old.
Yeah. Yep. I could. Yes, that is true. All right. Let me paste this link in the chat and then we'll be able to rock and roll. So generate link. There we go. Copy. Okay, ladies and gentlemen, let's get back on track here. So restream. You guys need to be on this screen over here, and I need to paste this link into the chat right there. So that link, I'm going to pull it up on the screen. We're going to share the screen. Share the entire screen. There we go. Okay, let's maximize that and let's bring JR and I down at the bottom here. Okay, so the link that I just gave you, all basically contains these files. So there is a, let me make sure that this is a CRV file or else I'm an idiot. Yep, there is a CRV file that contains a project for making some clamps. And in that project, I'll pull up the image. Basically, you've probably seen these clamps online and everything. They're little wedge clamps. They have a kicker on the back that can kick up the back end to bring the force to the front end down. And you can use T-bolts or whatever you got. This particular picture shows it going into a threaded insert, not necessary. You know, you would use T-bolts or whatever you have. But that file, that Vectric file, has, I believe there's 3 rows and there's 3 columns. 1, 2, 3, 4, 5, 6, 7. So 21 clamps here. And it's set up for a board that's 24 by 24. Now, if you don't have room to do a 24 by 24 sheet, then you can just take some of the vectors, right? You could do just, you know, maybe the first 6 or the first 9 or whatever, and make your sheet smaller, make your board smaller. I use in this, you can use hardwood or you can use plywood. Don't use MDF, too much flex and too easy to break, you know, kind of thing. But it has, this file has all of the tool paths for cutting out the parts. And then in the files that I gave you, in the files, there's a README document which has the instructions, text instructions. It also has links to the 1/4-20 knobs, the T-bolts, the threaded inserts that go into the back of them, the carriage bolts that have the flat pad on the bottom of them. So that's what gets used to jack up the back end. And it has the, let's see, it has the threaded inserts. It has the carriage bolts themselves, T-bolts, and knobs. So yeah, so it has all the links to all the parts and everything. Now, the project, the clamps that I made were made out of plywood, but again, they can be made out of hardwood as well. I have them set to where the clamps are 3/4 of an inch. I'm sorry, a 1/2 inch thick. There's no reason for them to be 3/4 of an inch thick. It's just too much. So I was using, you know, a 1/2 inch plywood, but you can also use 1/2 inch wood material. Like I said, it could be hardwood or it could be plywood. Made out of plywood, but again, they can be. Sorry, we have. Sorry about that. We have everything right there. The general information is right there in that text document for you. And then just some pictures of the items and then some screenshots of the tool paths. Because the DXF file is in there as well, if for some reason you're rocking an older, much older version of the Vectric software and you cannot open the project file in Vectric, there is an not an STL. There is a DXF and an SVG file inside of the folder that you can bring right in, and you can use the pictures 1 through 5 to literally recreate the tool paths and everything. And it shows you what vectors to select, and then it shows you the tool path and the tool path settings. So you should be able to recreate this if you cannot directly open the CRV file that's in there. But anyway, these are some nice little hold downs, and they're decent size. I mean, they're pretty decent size file or clamps. They are overall about 6 inches long and 2.5 inches wide at the widest part on the tail end of it and everything. And I believe they are 1.75 inches or 1.5 inches or something at the base. Let me see here. Vertical from here to, come on, lady. Escape. Yeah, 1 3/4. And they're nice little clamps, make for DIY, for making them yourself and stuff. Good little hold down clamps and everything. Now, the file itself uses a 90-degree V-bit, 1/2-inch diameter head, 90-degree V-bit, as well as a 1/4-inch end mill. Just those 2 bits to make the entire project. And again, you can break it down if you can't do a 24 by 24 for whatever reason. You can, make 3 clamps, make 6, make 9, make whatever you want. Just change the size of the wood and change the size of your vectors that create the little chamfer on the end. Okay, so we'll talk about that a little bit more in just a moment. Let's see here. So that's kind of that idea. Now, what I want is, let me pull up in the downloads folder. Pull up some images. All righty. Almost there, ladies and gentlemen. I'm trying to get everything kind of organized. Give me just a second here. Okay. All right. So, can everybody, oh Lord have mercy, why am I so scattered right now? Sorry, everybody. I'm trying to be fluent in everything. I just don't have enough. There's JR and everybody. Okay, hey, let's see. Turn on the chat. And Vince has popped in. Hey, Vince, how's it going, buddy? All right, and cold in Kentucky. I bet it is, man. I bet it is. I'm sorry, in Florida, it's not that cold. We got down to 17 the other night, which was a little cold for us. And the only experience that I've had, as far as the only thing that happened there was I have a crawl space. So our house is, kind of somewhat elevated. There's a crawl space, and I had a water line bust at 4 o'clock in the morning, freeze and bust, because it just got so cold. And so having to crawl into the house and fix that at 4 o'clock in the morning, that's, no fun. But that's nothing compared to what you guys and girls are driving in, dealing with, and closures and all that. So I really hope y'all are doing okay. And I'm glad y'all are able to sit down and take a deep breath and have some time with me tonight for sure. All right. So let's talk about what tonight is and what it isn't and all that wonderful stuff. So tonight is not going to cover every aspect of CNC clamping and hold downs, but I'm hoping that for the most part, that we can, I lost JR. For the most part, that we can cover some of the key things. I'm not going to get into full detail on vacuum clamping, right? And everything, which is its own beast in itself and all, and which is a very viable work holding technique for sure. It has its advantages and disadvantages and things. That I will reserve, because I do have vacuum pumps for small vacuum pods that I've used, as well as I got a larger vacuum pump for larger plenums and machines. And that would be a class in itself that I'd like to have a talk with and a discussion and stuff. But I'm not going to cover vacuum a whole lot here, because it's very hard to, not everybody has vacuum options and things like that. And I want to kind of keep this neutral too. Mechanical clamping, your regular normal hold downs, toenail clamps, those side clamps and everything that you see, cam clamping and wedge clamping, two-sided tape, CA glue and painter's tape, which is a really nice, cool option. When it's appropriate to screw your material down, when that's better than two-sided tape and things like that. So I want to just talk about, holding in general. And I want to, try to cover as much as I can and deliver as much as I can. But it's not going to be the albeit everything in the whole wide world, right? But it's going to hopefully give you something to use in your shop that you just real principles that you can, get to. And when I say clamping, now let's understand this and everything. I'm not just talking about forcing the board down and pressing it to the table and everything. I'm literally talking about controlling your work, securing the material in a way that that you don't get flex, bowing, any type of movement, slippage out from under the clamps, and things like that, and inaccurate cuts, due to poor clamping and everything. Because no matter what, a great tool path that is perfect in every way could absolutely fail if the work isn't held properly, right? So I want to make sure that we understand that we're talking about controlling the work, not just putting clamp pressure and everything on the board and stuff. And when we cut, we're gonna hopefully tonight we're gonna kind of understand the forces, your shear cutting, and what happens when your material gets cut and what those forces do, and when certain type of clamping is appropriate depending on those forces and things like that. So that's what my goal is and everything. So anybody that's beginners, you beginner CNC carvers or workers and stuff, even intermediate and advanced and stuff, hopefully there's something you can learn from tonight, and hopefully it benefits everybody. And we're gonna basically see what we can achieve. All right. The first thing is what we're trying to prevent. I don't know if I still, let me look and see where you guys are. I have to keep minimizing you. Yeah, on the screen. Let me maximize it back up. I wish I need a moderator that, can move screens around. All right. So when we're talking about the principles of work holding, mechanical work holding and things like that, basically we are trying to keep the material from moving, right? Stop movement. We're trying to prevent lift, edge clamping and side clamping and things. In a lot of cases, when you're using your upcut end mills and all, you're pulling material up. It's kind of like acting like a screw in a sense, and you could literally pull yourself up off your side clamps if they're not clamped properly. So we want to control lift, and then also on thinner materials, we want to control flex. We don't want to clamp so hard that we cause bowing. You'll see a lot of times, you'll see that a lot with thinner plywoods and things like that. We clamp down the sides and we put so much pressure on them, it kind of causes the material, because it not only creates down pressure, but it also creates pressure inward and stuff, and it can cause slight bowing in the middle of the cut. And so now we have a raise, or we have an air gap under the material that we didn't even realize was there, but we've actually created that. We by tightening down your clamps and forcing down your clamps doesn't necessarily mean it's not equal to good work holding always, kind of thing. It doesn't mean clamp harder. We just need to clamp smarter. Okay, so let's trying to get my notes here for everybody. And if y'all have questions in the chat, I'm going to ask if any questions or anything come up during classes, and I'll put a question mark in front of your question, or, you know, just a question mark or something in front of the question, like, you know, instead of at the end, so I can differentiate it from just normal conversation and stuff like that. And we can, you know, go from there. But all right, let's talk about really quickly the different types of clamps. Now, I just recently have started using the match fit system with my wasteboard. And let's see if I can pull up some general images here on the screen. Let's see if I can get you guys here. And with the match fit system, I have basically that's that dovetail bit match fit system from Microjig. It's great not just for CNC clamping, but all kinds of clamping in the shop. My workbenches and clamp tables and everything use the match fit system, and it's amazing. It only takes 2 bits to make the, you know, the wasteboard of the jig, an end mill, and your dovetail 14-degree dovetail bit. But inside of the wasteboard, I have a series of 3/8 inch diameter holes. These holes are spread out throughout the wasteboard so that they accept a 3/8 inch outside diameter by 1/2 inch long bushing, stainless steel bushing, so that the bushings act like a fence system, which allows me to clamp. It allows me to reference material up against to make sure that you know, I'm aligned with my CNC and everything. They're low profiles because they're only a 1/2 inch long, and the hole in the wasteboard is a 1/4 inch deep, so they're only sticking up a 1/4 inch. And it allows me to use, you know, clamps like my toe clamps for that side and downward pressure, pushing. The toe clamp is pushing that material in to that those bushings, those fences and everything. Now, what we don't want to happen is, you know, if we're overextending our clamping, or if we're, you know, like if I was using mechanical clamping and everything, and I was putting a lot of down pressure, there's an opportunity. There's an opportunity where I could put clamp pressure here, and it caused my board to like lift on one end. You know, I'm literally putting so much down pressure here because there's no clamps on the other side. They're just referenced up against the fence. But even if my board is flat, there's a potential that, because I'm right on the edge of the board, there's a potential that I could cause that board to slightly lift on the other end. And we don't want that to happen and everything. So in this instance, the toe clamps provide a inward and downward clamping pressure, and the bushings on the other side, you know, are getting the board's getting forced into those, and it's creating that holding power so it doesn't lift and all. I like this using these bushings and stuff for my alignment fences and all, but I don't always use toe clamps. There's always there's times where it does, even the toe clamps cause the board to kind of lift and ride, especially, and there's potential with the clamp that you see right now on the screen. There's potential that if I was using an upcome bit, that I could literally lift that board right off the you know, out of the table and everything. So when I'm V carving and things like that, this is an ideal simple clamp setup for me. I'm not really concerned about lift and all, versus when I'm doing big pocket cuts and profile cuts and things like that. So what I want to talk about is, I want to talk about the different clamps and kind of give an idea of, you know, when they're, you know, best to be used and when not. And so let's start off with wedge clamps and cam clamps. And man, if you don't, gosh, I wish I had some reference pictures. I'm going to have to pull reference off of the internet for a lot of this, but let's see here. Wood wedge clamping images. Wedge clamps are amazing little work holders and stuff, and they come in all kinds of little varieties and stuff. Um, Basically, what a wedge clamp is, and let me get everything bigger. I'm just so minimized and all. But basically, what a wedge clamp is we're using a wedged piece of material between the fences, the board that are, or whatever, a board, or in my case, my little dowel pins, that the board is referenced up against those registration pins, if you will. And then a wedge is coming in between a fixed fence and the material, and it is causing a force to push that material in to our fence system, if you will. The registration pins, it could be a piece of 90-degree wood, it could be anything, but it could be a series of wedges and spacers and everything to create that clamping pressure. And there's lots of different methods and stuff that are used with that, and there's a lot of different hold down styles and all. Now there's a neat little wedge clamp tool out there from UJK. I think it's UJK. Yeah, UJK clamp wedge. It looks like a little duck. See, I'll pull this up. And this is a little cam. It's a great little cam. And this system, it comes with registration pins. They're a little bit fatter, but though, they're about, a 1/2 inch to 5/8 inch in diameter, the little dogs, if you will. And they sit high, unless you have these big gouging holes in your wasteboard and stuff like that. So I don't use the pins that would come with them and stuff, but the little wedges and the fixed fence and the little cam. The cam is pretty slick. It slides right onto that pin, and you could DIY this, but give UGK some credit. But there's a lot of different options with this camming option and everything with the wedges, and it's a great wedge clamping is a great alternative to toe clamping or side clamping and everything. Having two fences fixed on your CNC machine, and having two fences fixed on your CNC machine, and then a wedge and a cam, and the wedge, you doesn't have to have a big angle on it or anything weird like that. All you're doing is your fixed holes. My dog holes, I got dog holes, those little, let's call those little bushing holes dog holes. They're all over the table, right? So I just find the closest dog hole, and then I can put my wedge in there, and then I can use a cam a cam to press, apply pressure into it. So wedge clamping is great, and cam clamping is great, and it's best when you are putting it up against a fixed stop. So in my case, it would be my bushings would be my fixed stops, or it could be, you could clamp some kind of board on the table or whatever. Now, the clamping force, which is the cam and your wedge, pushes the material and traps it into that fixed fence, and to prevent moving. If we can prevent movement, right, that's the number one thing that we do, is we're trying to prevent movement. Okay. So if in 90% of the carvings and everything, if our board cannot move on X and Y, very little chances they're going to be, lift, unless you're doing something like deep pockets, or using, upcut bits or compression bits or something where there's that pulling force. It could act like a screw, like, pulling it up. But if you're clamped well enough, and you're secured well enough, and it's trapped and it can't move, a lot of times you're not really going to get a whole lot of lift. But when I'm doing V carving, or I'm doing mortise and tenon cuts where I'm using a down cut bit, or when I'm doing 3D model carving with a ball nose bit, finish carving all, I have no problem with using a side clamp, toenail clamp, wedge clamp, cam clamp, anything like that. I'm not worried about the material lifting. The only time I'm worried about material lifting is when I'm doing, like I said, pocket cuts, deep pocket cuts, profile cuts and things where, you know, I want to use an upcut bit. There's a potential I could lift it up if the bit, you know, catches or snags. So I'm getting all over the place here. Wedge and cam clamps are best when you're up against a fence, right? You got to have some kind of fixed fence. Otherwise, it's kind of pointless. The clamp force, it pushes into those reference, but the mistake that we, you know, make is we use them standalone, the wedge standalone, and we're creating the side pressure and all, but we're not creating any of the down pressure, right, to kind of hold down. So what we want is on your wedges and things like that, we want to have where there's just a slight, you know, angle to your parts, so that when we are pressing in, that it's actually kind of creating a downward force. If we ever look at, let me see if I can pull up a toenail clamp here. Toenail clamp. Hold on, that's the wrong kind of toenail clamp. Oh my God, hold on a second. We don't want to see that CNC toenail clamp. Lord of mercy. Jesus H. Christmas. Let's get I don't mind. All right, so there we go. So pulling up people's toenails and stuff online. So a toenail clamp, 90% of the time when you see them, I like the Sane Smart toenail clamps. These side clamps, I have a couple of sets of these and everything. They're made by Sane Smart. That's the same people that make the Genmitsu CNC. But they're really nice little toe clamps. But toe clamps, when we typically see those and everything, they are ramped downward. So they're putting that side pressure on, but they're also creating that downward force. Whether it be wood clamping or metal clamping and everything, it grabs that side and it creates the down pressure as well. So our mistake when we're doing cam clamp and side clamping and all is we're creating that side clamp pressure, but we're forgetting the downward pressure, you know, to help kind of push the material, keep the material in that downward motion. Again, helping prevent lift. Now, some, you know, toenail clamps and everything, not always, some of them are smooth and stuff, but also some of the toenail clamps have grooves carved into them. I'm trying to think of what I'm saying. Have grooves carved into them and everything, so they grip, you know, so they really grip and bite the side. Some people, I've never done it, and to me that's a big old extra step and everything. But some people, when they're doing profile cuts and cutting out their parts and everything, where like they're cutting a part out of a piece of board, they will actually use a biscuit joiner, or if somebody's fancy enough to have what's the Festool, domino machine or whatever. But anyhow, they'll use a biscuit joiner to create a groove or multiple grooves on the side of the board. And they'll use little toenail clamps that go in and clamp on the side. So they're low profile. They actually go into the groove and then hold down the material. So there's no clamps above or on top and everything. And it's creating the side pressure, but also it's creating the down pressure as well too, because they're kind of inside this little groove. And that's a cool little step. I've never done that or anything, but I see that a lot with people in their CNC videos and stuff, and it's a pretty cool little method. But anyhow, we don't want to assume that the side pressure alone of toenail clamps and cam clamps is going to keep the material from staying down on the board, unless we kind of generate that downward pressure by using wedges or creating that downward motion by using toenail clamps that automatically have that built into them and everything. Now, when it comes to mechanical clamping, on top of the material, holding the material down. The what we want is, and that's the clamps that like that file that I just gave you. Where's my pictures at? This bad boy here. So mechanical clamps, we're now clamping down. We want to make sure that we're not overhanging our wood too much, or we're not clamping in a sense where we think we're getting a lot of good downward pressure, but we're really creating, problem scenarios where wood can move and things like that. I have a reference image that is, give credit where credit is due. Oh, Lord have mercy. Who in the world are they? Carbide Create. They had, they had a clamping class, back in the day, and they had this graphic, and this graphic is phenomenal. It's just a great little example and a good little drawing and stuff like that. So shout out to them for that. But this really shows mechanical clamping's do's and don'ts and everything. And so it would be, I want to be able to kind of just talk about it and use this as our visual reference. So mechanical clamps, like those clamps I just gave you the file of to hold and everything. Well, if we start at the top here and everything, we have our left side of the column is our correct side. The right side of the column is our incorrect clamping and everything. Well, what we don't want to do is create a teeter-totter, or, a pendulum is not the right word. We don't want to create a teeter-totter of clamp where we think we're putting down force, or we're creating a force and everything, and we're actually kind of losing it on the back end. We do want to create a level plane with our clamp, or slightly elevated on the back to put more down pressure on the front and everything. That's what that little that clamp that I provided to you guys has a little kicker on the back. In this picture, they're using a block of wood as that kicker, if you will. But we want the block of wood to be at the very tip of the clamp, or supporting that tip of the clamp. We don't want it being in close to the bolt, because it creates a cantilever. It creates a cantilever effect, and we're not getting any nose pressure on the clamp and stuff. So we don't want to, we want to be kind of out at the end, holding that clamp level and straight and true, slightly elevated, not quite level. So in this image, the right side where we have a bolt in our clamps that I provided you, but this block is slid in towards that center bolt, it's going to create a cantilever effect, and we're going to lose our downward pressure at the nose where we need it and everything. So that's not going to be good for us. We need to be back on the back of the clamp, so that when we're creating that pressure, it's either creating an even or a down or a frontward pressure as we can. Now, the second row coming in, I see this a lot in everything, where we're using a long clamp, and digital wood carver, our wooden clamps that we give with the machines and everything, they're long wedge clamps. They're like 6 to 8 inches long, and we have our T-bolt and stuff on there, and a lot of times we have the T-bolt down low, so you can't really get too much of a ramp going on there at all. But too many times do I see somebody using a thick piece of wood, let's say 1/2 inch thick or 3/4, and their clamp is sitting at an angle, clamping down. There is absolutely no pressure. And if I can zoom in and point to it, that little air gap right there under the clamp, if there's air between the material and the clamp, then there's potential for movement, for that material to get pushed from the sheer force of the router, dragging and driving that bit through the material and everything. If we have air under our clamp, because we're kind of clamping like this instead of this, or this, right there, that air under the clamp, we have the potential of it, the sheer force of the router moving through the wood, just pushing through, moving that material. So movement, we've not accomplished goal number one, to prevent movement, lift, and flex, right? So on the three fundamentals, if you will. So what we want is that when we are clamping and everything, that our clamp is creating that nose pressure down and we're getting good, even contact onto our material. Do not wedge your clamps up at an angle like this. You know, even if you have to get a piece of block of wood, you know, a scrap piece of wood, jack up the back end, you know, and everything, and get that nice pressure, that downward pressure. All right. So third example, you know, of when you're using these type of clamps and everything and all, is on the work holding and all, we are clamping on thin material, and, you know, let's say a picture frame or a piece of plywood or something where it's slightly elevated, but there's no, where our clamp is, where our pressure of our clamp is, there's nothing underneath supporting it. So we're thinking we're doing all right, even though we're butt level, you know, straight across and stuff, we're level and we're creating that downward pressure. Well, now there's nothing under this that can keep the board from, you know, tilting up. And we'll see this, forget the picture, the drawing, it looks like a picture frame and all, like live edge wood. If let's say I'm carving a piece of live edge wood and I happen to be carving on the bottom side, if you will, where the live edge is on the bottom side, it's straight, but it's kind of at an angle coming down and there's no air and my clamps are out here, there's potential that, you know, I'm causing tilt and things. So what we want is, if that case scenario ever, you know, occurs and stuff, what we want is we want to support underneath it, you know, stick wedges or whatever you got underneath to create some kind of, you know, reinforcement underneath when you're pressing, because hell, you could crush your edges too, you know, too much clamping force and all it does. Hard clamping doesn't always mean good clamping, you know, but you know, you could crush your edges and things like that. So we want to support that, but we also want to, you know, kind of create, in this instance, where we are taking the clamp pressure, the clamp, where all the pressure is happening is right here. And we want to put force, you know, kind of over the wide, you know, the thick part of this material here and everything. So we're creating that downward pressure and holding the material here. Putting clamp pressure back here is not going to be good for us, because again, we're working with thinner material, have a tendency of crushing it, you know, causing, you know, it to flex or bow and things like that. So we want to kind of have that as much down pressure as possible. So you don't really see a whole lot of that in the, you know, in the world and stuff, but I just want to, that's a good example. And then the last one they had here was, again, our nose of our clamp is where the clamping pressure lays. Okay. So we don't want to be overlaying and putting all the force here, because there we have the tendency of that part, when we're clamping, we have the tendency of that part kind of flipping up, you know, and everything. So we want to be back a bit, or we need to create, we need to put something here at the nose to provide, you know, clamp pressure. So if we're holding this part down and everything, then we want, you know, at where our clamp pressure is, we want all of our powers here and everything. So we want, you know, something to be under that, you know, providing that downward pressure and stuff. So a great little illustration from Carbide Create, you know, the drawing and everything. And it is, it really shows what we want. And our goal is we want to have either nose pressure, because again, that's where all your force is. We want that nose, you know, being slightly lower, where it's elevated on the back, where we have that down pressure when we clamp happings. Or if we're at a level, we want what we're trying, the main part of our body of what we're trying to clamp, to be under that nose. So that's why we want to prevent being too far on the material. Don't have your clamps like overhanging the material too far, because all the clamping pressure is getting dissipated, you know, off the tip of that and stuff. And so I thought I had Let me see. I thought I had another graphic. It's a terrible graphic, but I thought I had another example of it, but I don't. All I have is that one. But too many times so I see people, with the clamp like literally hanging an inch over their board and everything, where all the clamping pressure is here at the nose of the clamp, and nothing's really, they're not really holding anything. So again, we have potential for movement. So when it comes to mechanical clamps, it's a solid method of clamping all the way around, right? We have the ability to have, we can use it sparingly. So we could have 2 clamps on a project. We could have 8 clamps on a project, you know what I mean, on our board and stuff. But where we mistake is thinking that over tightening the clamp is a good thing and all. That doesn't help us, because all that does is create flex, bowing and crowning. It creates, tilt or tip. All we need is good, just down pressure. And we don't need a lot of it. You don't need to kill your clamps. Now, where we what we're trying to do is we're trying to prevent lateral movement, right? Eliminate lateral movement, that X and Y movement. We're trying to prevent lift, again, the 3 fundamentals, and we're trying to prevent, over clamping to where we cause a bow or something, or we crush our edges or things like that. So we want just a nice clamp. So once we understand the 3 fundamentals of clamping and everything, prevent movement, prevent lift, prevent bowing, or flex, let's call it flex, then, it kind of makes it, because when we're clamping, basically all of our clamps should be answering 3 things. One, is the material going to move? Is there any movement? Can I move the material after I get it clamped down? Number 2, am I crushing my material to where I'm causing it to literally lift up in the middle? I'm putting so much down pressure, even though I'm up against my waste board and all that stuff. I'm creating so much down pressure that I'm actually literally lifting the center, or I'm causing a flex. I'm putting so much pressure, it's causing a flex in my board. And you don't see that with thicker materials more so than with thinner materials. Sorry, I got the hiccups. You'll see that a lot with thinner materials. So we're answering questions, and if we can answer the questions correctly, then we're doing good. Now there's other clamping methods. Pneumatic clamping, 2-sided tape, painter's tape, and CA glue. When it comes to painter's tape and CA glue, while that is a good method and everything, and I use it from, more often than none now that I've gotten really, I've gotten to really use it to see how easy it is for quick, fast setups and everything, and all. But if you're using too much glue, your CA glue and everything between your 2 pieces of tape, your 2 pieces of tape are already causing a little bit of a lift on the board. We're creating an air gap. Even though it's a very small, thin air gap, we're creating that air gap between the wasteboard and the material. And if we're, clamping and everything, there's a potential of causing that flex and stuff. But if we use the painter's tape or the 2-sided tape sparingly, where we only have maybe 1 or 2 strips on it in things, we're lifting the material, but we're causing, flex to where when the bit's carving, it can cause the material to flex or be spongy and all. And I've had times where my glue, especially in this cold months and everything, where the glue is a little thicker than normal. So when you're spreading the very thin bead of glue, very, very thin bead of glue, during the summertime, it's real watery, or kind of, it's a medium density, but it's, it's more liquidy. But during, right now, it's really thick. So when it hardens, it creates this like thick barrier and stuff. And you just want to be mindful that you're kind of introducing It's a wonderful work holding method, don't get me wrong, but you're introducing the possibility of flex and stuff. So don't over clamp. If you are going to use clamps with your two-sided tape or CA glue, which really, that's the purpose of it, is time to prevent that. You want to make sure that if you are going to use any additional clamping and everything, that you're not creating a clamping force that's going to cause those air gaps to flex and stuff. But again, I digress, because typically you're using the CA glue and painter's tape to avoid having to use clamps. What we want to, what my goal is, what I want for you is, I'm hoping that I'm not just, rambling and not making sense. That would be brutal. But what I'm hoping is to get you to think about your work holding a little bit more, whether it be like where you ask yourself, do I need a jig for this? I love jigs when it comes to clamping. I love jigs when it comes to anything with my table saw, bandsaw, especially with the CNC and everything for work holding. We designed and made a jig in the last class for the shoe rack, parts and stuff. I love jigs. I really do. I really, really do. But not everything requires a jig, for holding and stuff. But we want to be able to, think about our work holding principles and figure out hey, do I need a jig for this or not? Or what I want to answer is what is going to give me repeatability in my clamping? What's going to maintain my accuracy? Because I could have a stellar tool path, but inaccurate clamping could cause all things to go to Hades. So what's going to give me accuracy? What's going to give me repeatability? And what's going to prevent, upward motion, flexing, or movement, right? So in accuracy, those three items kind of fall into that level. We want to create accurate, repeatable setups and stuff. Sometimes jigs are better, help us with that. Now, so understand that we are when we're talking about clamping, but we're not talking about, we're literally talking about controlling physics, if you will. We're talking about forceful clamping. Killing your clamps doesn't always mean it's good and everything. All we're trying to do, and I'm repeating myself over and over again, is those three principles: no movement, repeatability, accuracy, no flex. We're good to go. So, and the majority of anyone, even myself back in the day and everything, when it comes to clamping and all, I would to the point where I if I didn't get enough turn out of my wing nut, I was using wing nuts, metal wing nuts, I would throw a pair of pliers on those bad boys, and thinking that clamping force is, going to do that. So in that, while I thought, oh yeah, man, that clamp ain't moving, all of a sudden, then I asked myself, well, how the hell did that board get pushed out from under? Because I was going, my bit was spinning too slow, or I was moving too fast, and it literally just pushed the board right out of the clamps. Like, what? I had that thing held down like crazy. Or, someone coming behind me and they couldn't unclamp the board. They're like, Jesus, man, what'd you do? And I'm like, oh, you got to use the wrench to take it off, or the pliers. It's not always good. So what we want to do is, instead of basically, thinking, how do I clamp this down, so it doesn't move, which is one of the things, but it's incomplete. We want to kind of ask ourselves, what's going to stop, chatter if our board is loose in certain areas, or if it's lifted and there's air between the material and the wasteboard and all. That's where we get chatter, bit chatter and things like that, inaccurate cuts and stuff. So what's going to prevent, you know, that chatter from happening, or what's going to prevent movement, you know, out from under clamps and create, you know, some kind of virtual explosion, if you will. Not like explosion, like blow up, but, you know, like just everything goes awry. We are, we're trying to just control lateral movement. All right. So, I'm trying to really put a key into this. When your router bit is cutting in the material, there is that downward movement from the Z up and down, but your cutter is actually creating side pressure. It is that bit is moving all around, so it's the side forces are crazy. You know, and there's a lot of power. Again, if you're, this is, you know, chip load, all that stuff. I'm not getting into that. We talked about that in the past and all that stuff, but, you know, right speeds and feeds and correct RPMs and everything, because when that bit is getting, you know, forced, you know, through the material stuff, it is creating a lot of pressure. And that, that lateral movement and all that sideways push, if you will, that's what, you know, we're trying to prevent. And, you know, with our clamps, the, that's why the registration pins, the dowels and stuff, and the side clamping and all are effective, because again, can't move on X and Y. And for 90% of the cuts, that's really all that we're trying to do, is just trap the board. It's the type of cuts, reiterating, you know, the pocket cuts, the profile cuts, the mortise cuts, which are pockets. Those cuts where we're using, you know, spiral type bits that literally are like screws going into the wood, you know, causing the wood to, you know, lift and everything. And our downward pressure on a down spiral bit, you know, we're coming in here on a down spiral, and that bit is, you know, constantly pushing down the materials and everything. We have a good, you know, opportunity for that. That's kind of keeping the material pushed down. Now, what it's actually doing to the bit, but though the bit is actually pushing itself up. And that's why you get a lot of fuzzies in the bottom of the cut. You don't really get a good, you know, smooth, clean cut on the bottom. It prevents that chipping and everything, but it comes down. But the upcut spiral bit, it's trying to pull everything up, including the wood that it's cutting into. And during the initial plunge and the initial cut, where the wood is mostly on both sides of the bit, that's where the potential of lifting it up out of the clamps happens. Now, when you're in a big pocket, once that first kind of cut occurs, and now the bit is really working on its, you know, its step over, let's say it's stepping over 40%, and we don't really have a whole lot of bit on all the way, a whole lot of wood all the way around the bit, then it kind of minimizes the lift from happening and all. But on that first initial plunge, drilling operations or pocket cuts and everything, where the most wear and tear happens on a bit, that's the potential, the highest potential where wood has to lift. That's why ramps are a good thing for tool pass, and ramping into a cut versus a straight plunge. Ramping helps extend the life of your router bits by reducing the amount of force on the bit or the wear and tear, but also it's good for preventing lift, because we're taking minimal pass as we kind of ramp into that cut and everything. But still, during that first cut, ramping is just the beginning of the cut. But in that cut, as we're going through, there's still potential. There's wood on both sides of the bit as it's coming through and everything. And so there's still potential of lift, you know, and also you don't see that a lot with downcut spiral bits or straight bits and all, but upcut, you'll see that some. So this is where man, I use side clamping all the time kind of thing, but you know, sometimes it fails because of the particular type of cut, but most of the time it works just great. You know, it's kind of hit and miss, and that's not the case. It's just a matter of, you know, for your V carves or, you know, cuts where you're using special types of bits or profile edge cutting and all, you don't really see the lift that much. It's when you're using certain bits and doing certain cuts and all where you see the most of the lift. And it's like, shoot, it holds before, but not now. So now we try to put in more clamping pressure, and that's not the answer. Let me see if I got how many people I have scratching their head right now. Hold on a second. In the chat. I got questions in the chat. Lots of questions in the chat. Let me see here. Yes. Okay. IDC. So, Blaze, give me a second. I'll answer the question about stream decks. Sorry, JR, are you talking about stream decks? When you say stream decks, are you talking about stream decks? That's what, yeah, I use a stream deck. And everything. I only have 3 screens and I need 4 monitors with everything, all the references and stuff, all the material, they're all over the place. But if that's what you're referring to on the stream deck, I use a stream deck when I'm designing and also podcast, but I also use a, which I can't drag it over because it'll screw up my microphone and all, but I also use a key switcher, for live streams and stuff. Okay. So anyhow, IDC is selling an edge hugger clamp kit. If you're talking, are you talking about that little black low profile clamp, the little one with just a single bolt coming through and there's really no length or anything to it?
Yep.
Yeah, that clamp does well. And one of the reasons why it's an effective clamp is because the bolt itself, coming down, that's creating the edge reference. When that little toenail clamp is, coming on the material and all, you've got that right at the nose downward pressure clamp, but the bolt itself, that's going into the T-track or the T-slot is creating the side reference. So it's an effective little clamp because it's it is so close to the wood by design and everything. It prevents that left to right movement, that lateral movement, and also it's creating the down pressure as well too. So it's an effective little clamp. If that's the one you're talking about, but it kind of it's accomplishing the two of the main fundamentals is preventing side to side movement, that lateral movement, and creating that downward pressure. And again, it doesn't require a whole lot of force. I don't know if you've seen any of the IDC videos and all where hey, you don't have to tighten it down very much, for it to be an effective bit. And that's true because too much force and all could introduce the flex and all that stuff. So we don't want to do that. But yeah, it's a good little bit for sure. Okay. With a multi-cut file like the one that you gave us, would one use both tape and side clamping to ensure the center items stay stationary? Well, number one, on that particular cut, let's see if I can pull it up here. On that particular cut, in the profile, I think I have them turned off. Yeah, I've got tabs turned off and everything because on this particular piece, I do use 2-sided tape and CA glue, David, on this. And I make sure that I have the tape that I use is the green frog tape, from Lowe's and everything. And I believe it's about 1.8 inches wide, or 1 7/8. It's a pretty decent width to it and everything. But I make sure that the strips of CA glue and painter's tape that I have are underneath the parts, because one, yes, I want to hold down that material and all, but also I'm using the tape and CA glue as a tab, if you will, even though my bit's cutting through that tape, and down to the wasteboard and all, cutting into the tape more so. But it's still where it's under the clamp, it's holding, you know, it's creating that and all. So on that, I always have the tape and CA glue. I always have it right at the edges. So I have 2 strips, one at each edge. And then in the instance here, I literally have a strip here, here, and here, down where the middle of these pieces are going to lie. And so my edge tape is simply for my edge to keep everything nice and flat. But the middle tape, yes, to keep the middle flat and everything too, but also it's kind of, for me, it's serving a dual purpose. It's holding the parts in place when they get cut out and stuff. That way I don't have to use tabs and everything. But if someone did not do that, then you definitely want to use tabs. But also, I would not have just 2 strips of CA glue and tape on each end without having something in the middle. And this is a 24-inch span. It's a really wide span. So having the 1, 2, 3, 4, 5 strips, again, they're about 1.8 inches wide, I think. Is not overkill by any means and everything, and it's creating a consistent flat plane without, you know, that's a 24-inch span, so there's a lot of potential for air gap. Even if I had 1 down the middle and 1 on each side and everything, there's still in between that center point and here, there's still a good 6 inches or so in between those strips of tape that have no... That tape and CA glue is creating a little bit of a lift, you know, and so that area is not making contact with the wasteboard. So that can cause chatter, you know, the board vibrating as it's getting cut and everything, and, you know, cause issues. Have any of you ever seen, oh man, if you ever, let me pull up a video. We can't watch it or anything like that, of course, but, you know, copyright and stuff, but on YouTube, oh gosh, what was his name? Hold on a second. Let me pull up the video. Upcut versus down cut. And Jonathan. Let me see if I can get mute that, make sure I don't have no audio coming up on my videos. Pause. Jonathan, if you have not watched this video, it's called spiral cut, compression versus upcut, downcut, and straight. You know, spiral bits, compression bits versus upcut, downcut, straight. Never seen before footage where he runs a high-speed camera with the cuts and everything, showing what each bit does and how much force it's putting on the material and everything. And this is a great video to show you exactly what's happening with straight bits and downcut bits and upcut bits and everything. This is a great video. And so in Jonathan's video, when that bit is cutting through and all, you can see that movement in that wood, right? You can see that movement there. Now, of course, that wood's, you know, there's nothing really holding it in and all that stuff, but that happens a lot when we start relieving, you know, parts, or we start relieving like those clamps and all, we're cutting parts out. Well, that material's gone while it's cutting the next clamp. So now that really has a potential to, you know, bounce or cause chatter and things like that. I can't, you know, have his video up very long, but if you ever get a chance, it's a 12-minute video, phenomenal footage. He did a great job with it. It's called Spiral Bits, Compression versus Upcut versus Downcut versus Straight. Never before seen 19,000 frames per second video. Great little video and explanation on those types of bits and stuff. But so David, because of that, because all those clamps are they're toe to toe with each other almost, you know, there's not a whole lot of space in between. So when one's getting cut out, that material is now gone to the next one. And so every time a piece of, you know, a clamp is getting cut out and stuff and cutting through, that's less material for the secure hold. So now we're definitely getting this. And if I only had 3 strips of tape or whatever holding that, then I'm really getting some bouncing and all. So I have a strip of tape under the center of each row of those clamps, and then tape on each side. I don't know if that helps or if that answers your question or not, but anyhow, one, it acts as tab. It's going to hold the parts in place. It's not going to hold them like really, really greatly well and all that stuff, but it's going to definitely reinforce and hold those in place while they're getting cut out. And also it creates, there's something underneath, you know, somewhat, it's not a lot, there's something on such a wide board. Okay, so let's see here. The edge hugger clamp, the Stream Deck. All right, that looks like all the questions there are good. Okay, all right, not bad. If you have any questions, ask. You know, please, if y'all have any questions, just ask. Okay. Let's see here. Give me just a moment. Give me just a second, ladies and gentlemen. Come on. Okay. So, when we're cutting, let me try to rephrase here. Every CNC carve, every CNC cut that happens in everything creates 3 things. Okay. Creates forces. It creates forces in 3 different directions. Your sideways force, those laterals, X and Y, your lift, and then flex. And again, flex doesn't always happen, doesn't always occur from, you know, too hard a clamping, as I've been, you know, saying on the sides. But when we have, you know, improper clamping and everything, where it introduces flex and all, our cuts are creating a lift force. So it creates that flex, that bow, that chatter, you know, and things like that. That's why I was just, you know, with David and all, and talking about the, you know, the CA glue and the tape and all, making sure there's plenty in there, because if it's too spread apart, we're creating that air gap. Even though it's a thin 2 layers of tape with, you know, CA glue in the middle, it's still, you know, it's still a lift, you know, and we're introducing that. Now my bit is producing a cut that's going to cause more lift and all. So we're trying to prevent all that. And that's where, in some cases, where screwing your material down in random places, in, you know, also helps and stuff. What our job is to, one, don't overpower the clamping. You know, too much over clamping that's not the answer, and everything. But, you know, proper clamping, like JR brought up, IDC's little edge profiles. They're little suckers, you know, and they have a bolt, but that bolt, it brings everything closer to the wood. So the bolt acts as your reference, to prevent that lateral movement, and then the downward pressure of the clamp itself, the little black clamp, is preventing the lift, right? And if you over clamp it, then you could introduce the flex or the chatter and all. So that's why even oh shoot, Garrett, even Garrett, says, hey, you don't have to over tighten these, right? And all that stuff. Also, don't over tighten them because they're 3D printed parts and they could shatter and stuff like that too. But they are very effective little clamps for sure. All right, so what our job is we're is not, don't overpower the clamping and all, but give those lift, sideways movement, flex. No, don't introduce them or don't give it anywhere to go. Your job is to make sure that the work piece can't move. It can't lift, it can't flex, and that's what we're trying to prevent on every job. So when the cutter engages the material, it's always pushing sideways, right? That X and Y movement. Even the plunge cuts are creating lateral forces and those sideways movement, believe it or not, and everything, depending on, again, the type of plunge and stuff. So wood is not rigid. We just got to understand that. It is pliable, and the thinner the material, the thinner the woods and all, the more chance we have of chatter, flex, instability happening and occurring. And again, we could have some stellar tool paths with that. We've thought of everything and everything, but if we have a bad setup, then we're going to have bad results, no matter how good our design is, no matter how good our tool path is, and everything. So just understand that wood compresses, so over clamping can cause you to crush your material and stuff like that. So we have compression that we want to prevent. We don't want to crush our material. It has the tendency to, in some cases, very smooth surfaces, those wedge clamps where we're clamped up on its side and everything, and make sure that I can be seen down here in the corner. When we have our clamp where the nose is up high and the tail is down low and we're clamped at an angle like this and all, it's already a slick surface to begin with, so there's definitely a chance of movement and stuff like that. If ever you've been carving and if ever you've been carving and your board moves out from under your clamps and everything, you're like, how the hell is that? Go back and look at your clamping and make sure that you're not missing or you're not kind of not taking advantage of that nose pressure, that downward pressure and everything. So when it comes to the laws of work holding, if you will, our job, law number one, is stop the side-to-side movement. That is absolutely number one. Whether it be edge pins, some kind of wooden fence, just clamps on all four sides. I don't care what it is. If you screw a board on one side of your project board and screw another board on the other side, screw another board on the front and screw another board on the back, so it's trapped, then you've basically accomplished your goal, right? You stop movement. Law number one. The statement is it is true. One solid stop, is better than is in a lot of cases is better than several clamps, and everything. So it doesn't need, it does more than, a good stop from moving and all can do more than 3 or 4 poorly placed clamps, right? The second, let's see here. I'm trying to see if there's any key things that I want to talk on that. No. So the second law is, again, control lift, right? So we underestimate a lot of times on how much lift could occur from the cuts and all, because we may not know. We probably have never experienced it, or may not have ever experienced it. That we've never seen a board get lifted by an upcut bit doing a pocket cut or anything like that. We've never seen it kind of, raise up. That video that I just showed you from Jonathan and everything, man, it's an eye-opener to show you what those bits are actually doing to the material and stuff, and how much lift is actually occurring for each of those cuts. Gosh, do yourself a favor sometime when you get some time, watch it. Not right now while we're having class, but we want to control lift, and we underestimate how much it actually happens in a cut. So if we hear chatter, if we are getting a lot of tear out on our material and stuff, if we're getting dimensional errors, in our cuts and all, a lot of that is going to be from flex and lift, because as the board is cutting and everything is lifting, and we could actually be removing more material than we're supposed to on that shear cut and everything. And even though it's fractional, minimal, we could see dimensional differences from what our cut should be versus what it is. The only place I could see where you would really see it would be inlays and things like that, where you would see like, whoa, why is that pocket so big? Or why do I have such a glue gap there? Or not glue gap, but such a gap there and all. Because we've actually, we've introduced or lifted, we didn't really have a good way of controlling it, or whatever the case may be, but we actually removed more material than we expect to do. So chatter, tear out, dimensional errors, dimensional cuts, dimensional differences from what we should have versus what we get. All that can be, caused by lift. And upcut forces exist. Those upcut forces exist when we use compression bits. When we use finishing passes, finishing pass is like that final pass, and it's a minimal thing, but that final last pass option in the toolpath, we're stepping away from the cut by a certain amount. And for most of all the passes, except for the last pass, we're cutting away by that difference, that offset that we put. But then on that very last pass, the bit is coming over, and it's taking that full final plunge, that final cut, taking the full depth of whatever material we actually left by the setting in our final last pass. And that, depending on the type of bit and everything, there's a lot of lifting force that can happen right there in everything in that cut. And that could be a profile cut where we're cutting out parts. And so we're introducing, lift and all. And that final pass is for, giving us a nice clean edge and everything, but lift is getting introduced in that type of cut. So sometimes it can be avoided, sometimes it can't, but we want to try to minimize it and all. Let's see here. If your clamp nose, or if you're over clamping your board edge too much and you're creating a lever or cantilever, if you will, a lever, then you're not really getting any clamping pressure and everything. You should not be overhanging your board too much, very small amounts. And you want that nose downward pressure and everything. That's going to kind of help prevent that. All right. So basically, if your clamp is acting like a crowbar, you're already losing, right? That kind of thing. Okay. So now, let's see here. Some key points with that. Let me see if I can summarize this with these key bullet points here. Downward force must be applied over supported material, right? So downward force is, we're trying to create that, that downward clamping, whether we're using toe clamps or not, we want that downward pressure as well as that side pressure. And for mechanical clamps, we want that downward pressure, just not over pressuring it. Clamping past the edge causes rotation. And basically what that means is, clamping past the edge where that nose isn't getting a lot of force and everything, we're defeating the purpose. We're not getting the clamping pressure we should be getting. Toe clamps, if you're going to use toe clamps and cam clamps, they have to be backed by solid fences, whether it be your registration pins or, wood that you have, screwed down into the side. It's got to be backed by that that solid foundation. Otherwise, they're, again, can cause issues and stuff, and they're not going to do what they need to do. And then wedges, if we are using wedges and all, they must not just push the material sideways, but they need to create a push and a downward pressure, just like the toe clamp has to have that downward pressure. A wedge has to have the downward pressure as well too. So everything is down. We're trying to create that side pressure and down, or that mechanical clamping and down. On the two-sided tape and the CA glue, we're creating a little lift. So there's, if you have sparing tape around, then your center area has a tendency to lift and all. You may have to use screws or use more tape. Like I said, I've got 5 strips going across that 24-inch board versus just 3, that kind of thing. Now, flexing your material is a silent failure, right? Sometimes you don't see it. If you've ever, let me see, I don't know if I have a picture of on my clamp. No, I don't have a good picture, but I've seen it so many times when I'm working with plywood and stuff in thin materials. I've got my board, I've held it down, I get my clamps, tightened and everything, and all of a sudden I'm looking from the edge, from the side and everything, and you can literally see the board on the corners where I have my 4 clamps is great, but right in the middle, there's literally, even though it might look so minuscule and stuff like that, there's a lift there, because I've kind of introduced a bow into my material in a sense, and I've created that lift and stuff, that flex, right? So a part can be held down, but it can still flex. So where you're going to see this is thin materials, thin parts, they bow. MDF compresses, so you could have maximum force on the edges and everything, but it can cause flexing and stuff. So over clamping can introduce that flex in there. And then of course, unsupported spans, right? That 24-inch board reference that I just said, that can cause flex and stuff. So what flex, what you'll see, what happens with flex and everything is when you're doing pocket cuts and things, when we're doing those cutouts and all, we're just talking about inlay. I said inlay would be where I would see, something like that. Again, your pockets, even though it's fractional and all, could be oversized and all, because we're cutting on a flex and stuff, and then when the board relaxes, it actually opens up, and it's like, ooh, I'm slightly bigger than what I was supposed to be and stuff. So we can flex, we can see oversized pockets, our walls. So flex can occur when we're like in our drilling and our our boring holes and stuff like that, where the first pass of the hole and cut has like slightly tapered wall to it. It's not really that straight. It's kind of wallered out. Wallered is actually a technical term and everything. So it's wallered out. And but we can see that tapered wall. Fuzziness, poor finishes, tear out, chipping, all that can be done, can be, because of flex, because, we're not, secure hold. And then, of course, inconsistent depths. The center of the board, I'm cutting out here and everything, and my depth is normal and all, but in the middle, for some reason, I'm deeper. I don't know why, because I'm flexing up and the bit's actually taking more material and things like that. So inconsistent depths across, your pockets, or or your fluting, or whatever, whatever type of cuts and stuff. Inconsistent depths is, is a sign of flex. And so it's not something that presents itself like it's not like obvious, and everything, but it's stuff that we have to watch out for. And if you're experiencing those things, like, then you need to look, fundamentally look back at your clamping setup and all, because a lot of projects, the flaws and the failures and this and that occur from insufficient clamping. It's just a true story. Okay, so let's see here. Let me see if this is supposed to be only an hour and a half, and we're an hour and a half right now. So we're trying not to go too much further. But let me see here. Okay, David, now hold on. So David has a question. So why would you not just use a compression bit to prevent the uplift problem? Compression bit creates an uplift problem because the bottom part of that bit is an upcut, David. So it's pulling up the bottom part of the bit. So you wouldn't use a compression bit to prevent uplift. It just does, it's not going to, because the upcut is what's causing the uplift. It's literally pulling it up at the bottom of that bit. So we wouldn't want to use that. So a compression bit would not be the answer to prevent uplift. A downcut bit, would help with, preventing that. A straight bit would help with preventing that, but just better clamping, right? Would also help with that. So whether it be two-sided tape, CA glue, or screwing your project down, adding screws throughout your project where the waste areas are, where you're actually securing it down and stuff would help. And yeah, so JR, as he said in the chat, he's used shallow pockets to stop side to side, movement and everything by creating shallow cuts and reducing that and everything. But just be mindful that the too many passes and everything, JR, just be mindful of, excessive, burning on the material or, creating fuzziness or rough edges and things like that from just too many excessive passes and all that stuff. But yeah, that works too. And everything. It's you need me? No. Okay. The, basically, if it flexes during the cut, you will see it after the cut, kind of thing. All right, so let's see here. Are there any key points with that? Support matters more than clamping pressure. All right, so that two-sided tape, those extra strips and all that support, it all matters more than clamping pressure. Again, we don't want to over tighten our clamps. That doesn't do anything. That doesn't help at all. Proper clamping on the nose of the clamp, the downward clamping to create that downward force and all, not doing cantilevers, all of that stuff is the problem and everything, not the clamping force, not how tight you tighten your clamp. That's never the problem. So support matters more than pressure. Distributed support, distributed clamping, clamps, properly, whether it be the extra tape strips on the two-sided tape or the CA glue or the extra clamps and all, distributed support beats point pressure at any time, and meaning that like when we're using C clamps and stuff, like clamps when we're clamping boards and panels together, when we put a clamp in, there's that, I don't know what the degree is. I don't know if it's like 120 degree, but there's 120 degrees of clamping force, that kind of comes out into being. So you put your wood clamps ever so far apart so that they cross each other, so that force kind of cross each other, and it creates that even force all the way across. Well, point pressure is, where you're getting, clamp pressure at this one specific point, but it's not distributing or fanning out or what have you. I can't really think of a good, because most clamps and everything do kind of create a fan of pressure. So single point pressure might come from side clamping and stuff. I can't really think of a good example of point pressure. just remember that, you know, waste boards are structured components, not accessories, right? So they are, you know, they're waste boards. They're sacrificial materials to, you know, prevent the damage of your table and all that stuff. But they're also means of, you know, providing, you know, a good source of, you know, clamping options and availability and all. So if it's just a flat sheet of MDF you have thrown on the table, you're kind of limiting yourself on the different types of clamping you can do versus something that uses, you know, like the jig that you see on the table or on the screen, where, you know, there's opportunities for all kinds of different fixtures, jigs, clamping opportunities, and things like that. Okay, so let's see if we can kind of let's see if we can spend just a few minutes on this. Why clamps fell, right? Why clamps fell? I don't want to harp on it too much. We talked about that nose pressure, you know, being, you know, improper clamping pressure, where, you know, there's actually nothing holding it. That, you know, we're creating that if there's air gap under your clamp, there's movement kind of thing. We've talked about that, but if we're not clamping correctly, we can almost be assured that examples of, you know, clamping is the forces of the clamp are you know, too far apart from creating good support. Let me see if I can explain that. I have my fence, my dowel pins and everything over here. And on a small board, my side clamp and my back clamp are pushing that material into those little registration pins, if you will. And I've got good side pressure. You know, the toenail clamps are providing some down pressure and everything, and all that wonderful things. And that's great on my smaller boards and stuff and all. But let's say my board gets bigger and my fence and my registration pins are way over here, and I have one little clamp back here and one little clamp in here, you know, trying to prevent, you know, to clamp, you know, to provide ample clamping, you know, into my fence and stuff. It's not going to cut it. They're too far. The clamping force is too far from the support. So we've got to more. We not, you know, necessarily more, but we got to be closer together. We got to, you know, we got to provide ample, you know, forces all the way around, that we're not spreading ourselves too thin. We're not, you know, the force applied is at the, you know, at the wrong angles and stuff. And hell, at that point, you know, I could be providing some side force and stuff, but I'm too far away from my reference fences and all that. It's pointless. I'm on my reference fence side. There's really nothing really holding it in that lateral movement. So, you know, I get, you know, lift, or I get, you know, chatter, or I get this or that. So there's no, we're not getting the clamping, the security that we need where we need it, and things. And if we're beside the side force and being too far away, improper clamping is, again, if we're not using that nose pressure and everything, and our clamps are hanging too far over our board, then, you know, we're creating a lever and not a press, you know. And we want to create a press. So the clamp, no matter what it is, you know, even the side clamps, like I said, that they have the little down ramp to them and all. Basically, a clamp should compress or press, not pry, right? We don't want to lift. We want the downward pressure. I don't really have a whole lot more on why clamps fell. Let's see here. basically, if the summary of that is if a clamp is doing more work than the table, then you built a lever. You didn't build you don't have a clamp, so you've got more of a lever, not a setup. All right, let's see here. The registration bushings that I use, right? They help with the pins themselves, being low profile and everything. They don't fight the cutter. They help with keeping things aligned. Um, they're not clamps. They're just registration pins, on that side. They're not clamps by any means, but they help keep the material aligned. They they don't fight the cutter. There's no clamping forces and all fighting the cutter, like I said, causing that wedge or pressure or anything like that. Where it's like literally fighting the cutter and creating inconsistent cuts. Um, they help with removing certain uncertainties with as far as am I square on the table, or is my surface cut going to hit any clamps or anything like that. Sorry about all the bings and dings. Um, the They're a good little system, and uh, in the little setup that I use on my tables and all with these little bushings and all, it gives me a lot of versatility for being able to use my cams, my toenail clamps, my wedge clamps, mechanical clamps as well, because they're low profile, so I can still put clamps all the way around on top and stuff. And they're just, again, they're quick and easy for me to be able to make sure my board is straight. Uh, I have repeatable setup, repeatability. Every time I clamp a board, they're all going to register from the same place. And so they define that repeatable position. They spread the load into the wasteboard instead of, in certain areas, they help spread the load, because I've got them, separated like every couple of inches apart type of thing. And then but always know this, that pins locate, reference, they don't clamp. They're not clamps. you know they help that lateral movement and everything, but they're not clamps, so don't just solely depend on your pins, and everything. uh I don't really, man, let's see here. All right, here's a good little last note, and all that is basing work holding off of the tool pass. So um tool pass, your cuts and all, they're not neutral, right? So the force direction, the force magnitude, and the force mode, basically climb cutting, right, pulls into the cutter. Conventional cutting pushes away from the cutter. Roughing, 3D roughing and things like that, that creates more lateral force than finishing cuts. Um, you don't just secure the part, right? Um, you you don't just secure the part for the project. You secure the part for the cut, for that cut and everything, because of all the different things. So um, the whole rambling of tonight and all, and I really think it's rambling, but it's still informational, is just to get you to think about your setups more and your clamping more and stuff, because it's not just it's not just throw some hold downs on the board and start carving and all. There's reasons for it. And again, our three fundamentals: we're trying to prevent movement, we're trying to prevent lift, we're trying to prevent chatter or flex, right? That's the third one, basically. Chatter, flex, rough cuts and things like that. But we have to think about the type of bits that we're using, and what bits how they act, and what cuts create lateral force, And then, every cut creates some kind of force. And like I just said, that climb cutting method, which is what we do most of all our cuts, that's pulling into the cutter, and everything. When we're climb cutting, we're pulling into the cutter. When we're conventional cutting, where it's kind of pushing it away from the cutter, those lateral forces and stuff. When we're rough cutting, that creates like 3D rough and rough cutting pockets, and stuff like that. We're creating more lateral forces with the rough cutting than we are with the finished cuts, the finished touch-up cuts and things like that. And so the with every cut that happens, there's forces at work there, trying to lift, trying to move, trying to cause havoc with the world. And we just got to think about our clamping methods and what we do. And are we using reference pins? And are our other two clamping forces too far from those reference pins? Are we using two-sided tape, and are we only using 2 strips of two-sided tape when we should be using 4 strips of two-sided tape, or the tape and CA glue? The over clamping or torquing down your clamps is never the answer, right? The proper clamping method, is my clamps, are my clamps, am I getting that downward pressure, or are my clamps losing that pressure because I'm kind of clamping like this instead of like this, right? We're creating a lever instead of a press, right? We want to create presses. And you'll know when clamping fails and everything. Most CNC accidents occur when your part moves or shifts, when a board lifts into the bit and goes crazy, and sometimes parts get flung across the room and stuff. When a clamp comes loose during the carve, if you've ever tightened down your clamp and you're carving and your clamp comes loose, and you're like, oh wow, that clamp came loose and everything, there was no pressure on that clamp to begin with, right? So you got to think about, okay, how am I actually using that clamp at all? Because the clamp should never come loose during a carve. It's like literally coming loose because there's no pressure on it. So the vibration and the movement of the machine and all that stuff is literally causing it to just loosen up, right? It's loosening its hold and everything. And that means it's a lever, it's not a press kind of thing. If we're crushing into our MDF, crushing our MDF or our soft woods and things, then whether we're crushing the sides into the pins or we're crushing the faces down, where our clamps happen to be laying and everything. If we're literally clamping and we create an indent in our material and all, we're over clamping. Pressure is never the answer. It's the type of clamping. You should never have. It does not require a whole lot of clamping force to have a secure hold. Literally. All right. So awareness, what to listen for, sound changes, right? We're cutting where the clamps are on the edge of the board and things sound good and all that stuff, but as the bit's cutting in the middle, we can start to hear a little bit of a tone difference, or we can hear a little bit of a chatter, a little bit of a vibration, and things like that. That kind of just, we might not be able to do anything right there at that moment and stuff, but that's something we need to be aware of for the next cut. You know what I mean? So we're listening for sound changes and stuff. And what are those changes? What sound, speeds and feeds and your cuts, audible, 90% of your chip load. And, if I've got the right RPMs and the right feed rate and the right this and the right that is audible. You hear it in the cut before you even see it. Your ears are faster by lightning speed, more so than your eyes and stuff like that, and the things that you observe and all. You hear it before it happened. You could be across the room and you could hear a tone difference before you even see what's going on and everything. So sound changes, vibration, again, chatter, if you can hear that and everything. Dust pattern changes, meaning your chip pattern changes can indicate, poor clamping and all, and failures and stuff, silent little failures and all, because of we're rubbing in certain areas and stuff, and not really, cutting into the material for, because it could be, caused by flex or compression or, different things. So the CNCs don't forgive hesitation. They a CNC machine is, they'll punish our assumptions. We might assume that we're doing the right thing and all that, but a CNC will let us know if we're not, kind of deal. But all right, so long story short is stop movement, control lift, prevent flex, make sure that your pins, if you're going to use alignment pins, they're for reference. They're not clamps, keep that in mind. But they can be used to trap the material as long as we're not too far away. Our clamp, on a big board, we don't want just 2 clamps, pushing into our fence and think that's enough. It's not going to be enough. So pins locate, clamps hold, right? And then, force direction of the router bit matters, how we hold our material. Good work holding is complicated. Do I need a jig for this? What do I need? Can I use 2 clamps? Do I need 4? Do I need 6? Do I need this many strips of 2-sided tape? So it gets all complicated and convoluted and all that. But, good work holding, once we understand the principles and everything, it's not complicated. Might seem like it, with everything that I've been rambling on about tonight and everything, but it's not complicated. It's intentional, right? We are clamping and securing our material for the cut, or the cuts, right? Cutter cuts. If you understand the forces, the hardware you need becomes obvious, right? The type of clamping you need becomes obvious. Do I need to screw this board down? Do I need to, are my side clamps enough? Are my wedge clamps enough? Are my toe clamps enough? Do I need some mechanical clamps, right? If you understand what's going to happen, in the cut and what forces are at play, then again, what type of clamping, what type of hardware and all, it starts to become obvious over time. And you become a better setupper. Is that the word? I don't think that's a word. Setupper is not a word. But you become better at your setups and stuff and your methods and all. And this is where, in a lot of cases, vacuum clamping, which again, we're not getting into that tonight or anything like that, but there's a lot of pros to that, consistent flow and hold and everything, but there's also a lot of cons too. It's not as effective on smaller parts, and when we are cutting parts out where we don't have a lot of hold and everything, and so we can't solely just depend on the vacuum alone. In some cases, we have to use little added things like a grip mat, or or additional, hold downs, or we might have to screw the material down in certain ways, or tabs or whatever. So while it is an improvement over a lot of things, it's not the all-be-it answer as well either. But we'll talk about vacuum clamping one day down the road. But that's all I have on clamps for tonight, guys. I don't have a whole lot. I mean, it's not a cool, fun topic where there's all kinds of cool stuff that we can do. All right, so let's answer some questions real quick. Now that you, let me see here. Let me pull this one up on the screen. Now that you've had the match fit spoil board for a bit, have you noticed any degradation in the match fit grooves from the clamping? No. That's another thing, right? That's another thing. What JR is asking on that one is, hey, from clamping and stuff, are you noticing any degradation in the grooves themselves, right? Because they're dovetail cut grooves. And let me pull so give me a second here. Let me get up a little bit where I'm bigger. So those grooves are dovetail, slots, and we're using little dovetail T-bolts and everything. And number one, the match fit of it all, those dovetail little T-bolts versus the clamping all. Again, it doesn't require a lot of clamping pressure. So we're not crushing or anything like that. And so what JR's question was is, hey, now that you're using the match fit bed, match fit bed over time, are you noticing a lot of degradation? Did I say that word right? Degradation, whatever, in the grooves themselves, right? And if I was over clamping and everything, absolutely, because we're thin at the top of the MDF, at the surface, we're thin at the top, where the walls are coming into the surface and everything, where it's open, it's not really thick up here and stuff. So if I'm over clamping and I'm really tightening down, I'm taking that dovetail shaped T-bolt and really kind of pull in, and what's happening is on the edges here, I'm crushing that MDF because MDF compresses, right? I'm crushing it and stuff like that. But it doesn't require a lot of pressure to get secure holds. So no, the answer to that is no. I haven't noticed any at all. But again, I would absolutely notice it if I was over clamping my bits and all, because I would absolutely be crushing those thin areas at the top of that dovetail groove for sure, 100%. And if you are crushing your grooves and stuff like that, then it's a sign that you're killing your clamps, right? And let me see if I can end this with, give me a second here on the when that bit or the T-bolt is in here and everything, there's not a whole lot of material here and everything. So the fit between the inside of this pocket and the outside of that little T-nut is a nice fit. It's a good fit. I mean, they matched them up very well and everything. There's not a whole lot of air gap or room to where I can get a whole lot of pressure to crush this and everything. But at the same time, don't over torque your clamps and everything, and you won't have any of that degradation and stuff. So degradation, I think, whatever it is. But yeah, so because it's thin in those areas right there, and that's where compression or degradation or what have you is going to occur. But no, the answer to that question is no. I have not seen that.
You didn't seal that board either, did you?
No. No need to. Yep. You can see the fibers when you zoom in.
Yeah, that's what I was looking at.
Yeah. Yep. It's crazy. All right, ladies and gents, I want to leave it here. We're an hour and 58 minutes. I don't want to go any further than that tonight for tonight's class. I want to try to keep this. It's supposed to be 90 minutes, but I rambled too much. This was not a project build tonight. This, again, I said that in the description. It was a discussion. It was a chance for a Q&A. We did. Thanks, Jared, Dave, and everybody who participated in the Q&A. And what I'm going to do is now listen, bear with me real quick while I say this. The shoe rack and the jig project for the shoe rack, the PDF and all that stuff, I will have that out. I was supposed to have this out this past week, but I had to get a ticketing system, a support ticketing system coded and out for Digital Woodcarver this past week and get it launched. So it kind of took me a little bit away from getting that project out, but I've got everything done with that project, all the files cleaned up as far as the design file and stuff like that. I'll be making the announcement like over the next day or two of the file when that's ready for download. But also I'm going to put together a nice PDF of just different types of clamping methods and their benefits and when to use them and when not to use them and stuff. Be a good little download for you, and I'll announce when that's available for download. All that'll kind of come out at the same time over the next couple days. I didn't get the shoe rack project out this past week again because I had to finish up that ticketing system. And just to brag a little bit, when a customer goes to Digital Woodcarver's website, they can now submit a support ticket, and the support staff within Digital Woodcarver are able to where's my right hole? They're able to manage those tickets and work with the customers and everything a lot more efficiently, manage their time a little bit more efficiently and everything. So just release that. It's just another way that, allows Digital Woodcarver to serve their customers and, kind of help them. And we can kind of keep track of, what service we've done with them in the past, if something kind of reoccurs and all that stuff, what we've done before and, and things like that. So had to code and get all that done and everything and all that back end stuff. So it kind of pulled me away from getting the shoe rack out. So I'll get that out here in the next day or so. And I'll make an announcement on the YouTube community page and the the SpindleTV Exclusive Facebook page. I'll get that out. And pretty soon I won't have to do announcements and all. They'll just all be available for download on the new SpindleTV Exclusive website, which I'll have access to and be able to set up as of February 26th. I'm waiting for that 60-day hold to end, and it's February 26th is the cutoff. So that stupid hold that they did to me, God, kills me. But anyway, you guys will like that, being able to have access to that website and those downloads and resources and stuff like that. I think I'm knock on wood. I think I've done a good job with that site. I just got to get it launched for y'all. All right, everybody. With that being said, y'all have a wonderful night. JR, thanks for hanging out with me on the screen. Remember, gold members, just like JR, you can come and spend time live on the computer screen while we're doing the classes and stuff. That's a benefit of the gold members. And keep that in mind. The link is always available for you to click on and join us live in the community page on the Facebook community page where the posts are. You'll be able to see that. But y'all have a great night. Think about your clamping and what you're doing, and pay a little bit of attention to how you do things now, and if anything ever needs to change, or if you're experiencing some of the things we talked about, and you're experiencing some of the issues we talked about, or what have you, look at your clamping first, right? And see if you need to make adjustments there, because that's 99% of the failures and all are going to come from, poor setup and clamping as part of that. All right, everybody.